Factoring is a legitimate way to try to help solve equations, but in order to use factoring, we first need to understand where did factoring come from, or why does it work? And it works basically because it's the opposite of FOILing, or the opposite of distributing. So let's do some FOILing first. So these three statements up top, basically FOILing, remember, is taking the first term of a two binomial expressions and multiplying, so you get x squared. Then we do the outside, so you'd have a plus 2x. Then we're going to add on the inside term, so x times 1. And then finally add on our last term. Again, FOIL, F-O-I-L, 2 times 1 being 2. You'll notice that right away, that middle term often, if these are two linear binomials, will be like terms. So 2x plus 1x gives us a 3x, and you get to add that middle term together. Now you can also take an x minus 4 quantity squared. We could separate that out, and you'll notice again that x times x is x squared. Your outside term and your inside term come out alike, and your final term will be 16. So again, you'll get to add those two middle terms, giving you 8x, negative 8x that is, in the middle. And that's kind of the same idea. Notice here we just have a couple of variables demonstrating literally exactly what's happening when you factor and add like terms. You're going to FOIL together, so x squared in the front, n times m in the back, and then you get two terms both having an x in them in the middle. So they're like terms, they would be able to add together, assuming that you could add m and n. That's where that middle term comes from. Now factoring is just saying we're going to start with the final statement and work our way backwards. So we need to figure out, as you noticed, what multiplies to the end. 1 times 2 gave us the n term. Negative 4 times negative 4 gave us the n term, or as you notice in the middle, n times m gives you that n term. So what's going to multiply to the end, but also what adds to the middle. Remember, we added like terms to get each of those middle terms up top. So great idea is to make a list right away. What's going to add to negative 48, or sorry, add to negative 2, add to the middle, but multiply to a negative 48. Well, if we're going to multiply to a negative number, we know that one of the two of them has to be negative. We also know that a couple of numbers that multiply to 48 would be 48 and 1. We can talk about 12 and 4. We could use 6 and 8. And there are many others, 2 and 24. There's lots of opportunities. Knowing that one of them needs to be negative, and they need to be 2 units apart then, if when we add them together, essentially adding a positive to a negative is like subtracting, and they need to subtract with a difference of 2. Well, you'll notice right away that 6 and 8 are 2 units apart. So if we're going to add to negative 2, we better use a negative 8. And therefore we can write two factors down, one of which is x plus 6, and one of which is x minus 8. They're going to multiply 6 times negative 8 to negative 48. And when we add those two middle terms, 6x plus negative 8x will be a negative 2x. Let's do the same thing on the right. What multiplies to 28 but is going to add to negative 3? So again, we're going to multiply to a positive number this time, which means they're either both positive numbers or both negative numbers. But we're going to add to a negative number, which means they must both be negative. So let's first figure out what multiplies to 28. We could say 1 and 28, both being negative. We could say 2 and 14, again, both being negative. We could also say 4 and 7, again, both being negative. And I don't believe there are any other factors of 28. When we add these together, you'll notice that we get negative 29, negative 16, and negative 11. Assuming these are the only factors of 28, then there's no way to add to negative 3, and we would just say that this is not factorable. There's a quick overview for factoring for you. Now there are some special cases that you can practice on, and one of those special cases will deal with perfect squares. Just like we talked about at the top of the last screen, x minus 4 squared is going to multiply to x squared minus 8x plus 16. You can do all the work in red, or if you know the shortcut, what we're going to talk about right here, we can skip directly down to what's in blue. The idea of the shortcut is that those first two terms will always be the same. So if you know that x is the front term here, then x squared will give you the first term at the bottom. Also, the last two terms in our two statements are both the same, essentially saying that negative 4 times negative 4, or negative 4 squared, will give you the last term. And the middle term always comes from adding those two like terms together. But because x and negative 4 are repeated, you're basically doubling whatever your front term, x, and your last term, negative 4, multiplied together were. So negative 4 times x times 2 will give you the middle. So that's the shortcut to the middle. Now that's going to help us when we talk about the perfect square pattern on the next page here. If I'm trying to factor something and I notice that the first and last terms are perfect squares, I might get lucky by just saying, well, hey, this might be a perfect square pattern. I know that 36 could come from 6 squared, and x squared definitely could come from x times itself. 25 makes me think 5, and now the real key, if I use my shortcut, is does the first term, 6x, times the last term, 5, times 2 give you the middle. And 6 times 5 is 30, times 2 is 60x, and I would say that 6x plus 5, the quantity squared, does work. Now having a negative in there does mess up our pattern just a little bit, but notice we still have a 4 and a 9, so the first thought that I have is to make this a 2x and make this a 3. But now if we're going to check our perfect square pattern, notice we need to come up with a negative 12, and 2 times 3 times 2, double the middle, does give us 12. The only way we're going to get negative 12 is to make that a negative 3. So 2x minus 3 squared, or if you notice the middle term being negative, make it a minus b quantity squared, will give you the middle. Okay, now there is another pattern, also called a perfect squares pattern, but this one's called the difference of squares. And the reason is, if we think about our numbers, notice we do have a positive 16 and a negative 225 over here, both perfect squares, although negative makes me think something weird's going on. But I would still think, if I had to take a guess, that 4x would help me get 16x squared, and 15 will help me get 225. The problem is, if we try to take 4 times 15 times 2, that's going to give us 60 times 2 is 120, and notice in the middle, we don't have 120, we have 0. We don't want to double the middle, we actually want to cancel it out. So I don't want to have two positive numbers making something like 60, or two negative numbers making something like negative 12. I actually want two opposites, which is where the difference of squares patterns comes in. The 4 and the 15 are good first thoughts, but we're not going to be able to use the same 15. One of them needs to be positive, and one of them needs to be negative. Positive 15 times negative 15 will give us that negative 225, but positive 60 plus negative 60 from the outside will give us that 0, that missing middle term. Notice there is no x to the first power in our statement here. So that's the difference of squares pattern. On the bottom, another easy thing to do when you're factoring, instead of trying to think of any of these larger patterns, such as the difference of squares, the perfect square, or even just what adds to the middle and multiplies to the end, a great idea is to think monomials first. What's in both terms on those statements on the bottom that you could just pull out in front right away? What could be divided away or basically undistributed? Since there's a 3 in both parts, I can write a 3 in front. Notice we also have an x squared and an x, so you could put an x in front. And knowing that 3x times x would give you x squared, and 3x times negative 3, if I distributed that in there, would give us negative 9x, we've actually simply factored the monomial, single term, 3x, out of our statement. So I would start with that over here on the right as well. Notice there's a 4 that would go into both 4 and 36. So we could factor that out of our statement. Then you'll notice that u squared minus 9, well, u squared is a perfect square, so is 9. And that's the difference, subtraction, difference of two perfect squares. So that makes me think of my difference of squares pattern from up top. 4 times u minus 3, u plus 3. And that is a well-factored, completely factored statement. You could have also factored from the beginning and gotten 2u minus 6, 2u plus 6, but then notice that there's a 2 in all of those parts. So if you factored a 2 out of the first part and factored it out of the second part, and sort of combine those, a 2 from the first and a 2 from the second, there's where that 4 comes from. And that would also leave you with your u minus 3 or u plus 3 in your statement. So another way to factor, it doesn't matter what order you do them in. Again, a great idea though is to think monomial first. Sometimes that simplifies the pattern. The final thing I want to tell you is make sure, even if you think it's a perfect square pattern, make sure it actually fits. You'll notice that each one of these numbers has a 36 as its last number, and it has an x squared as its front. So it makes me think that we've got some perfect squares going on. The problem is only one of these statements is actually a perfect square. Remember that we not only want to think x and 6, we also need to think x times 6 times 2. Which one of these will give us the proper middle? And that statement actually comes out as the one in the middle. X times 6 times 2 would be 12, and if I make that a negative 6, there's where we get our negative 12. If you really think about negative 13, it will actually come from negative 4 and negative 9, which still multiply to positive 36. And if you think about negative 37, it's actually negative 36 and negative 1, still multiplying to positive 36. So again, only one of those statements was a perfect square pattern. Make sure you check that middle term and make sure your pattern actually fits. I hope that helps you with factoring. Good luck. And in part 2 of the video, we will explain what factoring is actually used for or where it's really useful in algebra.